Normally we talk about our more modern products, the RMC tool software and controllers. Today we're going to focus on the RMC100 and RMCWin. That is an old goodie that's been around and still is around. The RMC100 is a long-lasting workhorse. Perhaps many of you are familiar with this. We have sold thousands of them. There are still many in use. There are still sawmills that have their controls mostly entirely done with RMC100s. That said, we want to make sure you understand that Delta will support its products as long as there is demand. Our obsolescence policy is to not obsolete products as long as there is demand. So there are products we've designed in the 1980s that you can still buy new from us. We don't necessarily have huge stock of them, and fortunately not many people buy them, but we will provide support. A little bit of history here. The RMC100 and RMCWin was released in 1997. That's a few years ago. In 2004, our more modern software, RMC Tools, was released 7 years later. So there was plenty of years where the RMC100 sold exclusively. In 2008, the RMC150 was released, and I'm sure many of you know that that is a CPU that can be a drop-in replacement to the 100 CPU, and that means a physical drop-in replacement. The programming is entirely different and requires that you reprogram your PLC to talk to RMC and so on. In 2016 was the last time the RMC100 had any update whatsoever, and that was actually a firmware update for Ethernet to bring the Ethernet software in the RMC up to date with modern Ethernet so it could work in networks and plants. And about the same time, our RMC200 was released, and of course now we are at 2021. So we see that that's roughly 14 years ago that the RMC100 started. We still sell them today. Every month we have 1 or 2 that go out. And again, the RMC100 is still supported. You can call us up. We will give technical support. You can buy parts. However, we do not recommend it for new designs. So today we are going to go over RMCWin, the main sections, the main screen here that we see, and the module configuration details, event steps, input to event table, curve tool, communications, and on the way a few more things. And we will try to focus on tips and tricks for troubleshooting, because most of you are doing troubleshooting now. You're not designing new applications with RMC100, hopefully. I actually have my RMC hooked up to a simulator that looks like this. Not the prettiest one right now, but it actually has a bar graph that goes up and down. Maybe if some of you have been around a long time, worked Delta product, you see one of these. So it's actually simulating position control and pressure. It gives me a visual. So I have that actually on my desk here, although you won't be able to see that, unfortunately. So I'm actually using the RMC to do real control here. So to begin with, this is the RMCWin software. You get to see a lot of the data right off the bat here on the front. So in some ways that's nice and simple. We'll just quickly go through the basics of it here. The status area, I have my axes, and I actually have axis 0 hooked up. We see command position, that's the final requested position. The target is where we are at, or where we want to be at any moment, and the actual position is where the feedback's telling us we actually are. We have the command area. This is where we send commands to the axis. You can set the plot time, and we have parameters for configuring the axis, such as the position, feedback, and tuning. But very simply, if I have the command area, I can set up a command. We'll go through the mode word a little bit later. I can set the acceleration, decel, speed, command value. Maybe I'll move to say 13,000. And typically in the RMC100, these values are in thousands of inches. So 1,000 usually means 1 inch. Of course, you could do millimeters or something, but normally that's how it operates. So I'm telling it to move to 13 inches. And in the command field, I type a G and I press enter. And now I see that the position is moving to 13. I can click the plot button and it opens a plot of that motion that I just did. So we see here in the cursor that it started at the target position was 1000, and over at the end, it didn't quite finish the move here before the plot ended. I would have to do a faster move to see that. We can try that again. I'll move to 6,000. That'll be a shorter move. And notice before I double clicked in here and typed G, if I just click once and type a G, well, I guess I got out of that mode. Sometimes if you just type a G, it'll go. But now I'm moving to 6,000, and you'll notice that the plot has the insert key as a shortcut command. So now on my keyboard, I just press insert, and I see that motion in the plot. So the basics of the operation here are pretty quick and simple. That's the beauty of the RMC100. The downside is that it's not modern, has all the fancy settings and algorithms that we have in our newer product. So that's just the very basics. We'll go through in detail now all the areas that you need to know from a troubleshooting perspective. The first one is usually, how in the world do I connect to this RMC100? In RMCWin, we have down here on the right-hand side on the status bar, the connection. So I can double click, and that opens up the options. I think I can also go to Tools Options here, right there. Yep, and that gets to the same thing. Communication tab. The two general ones we use are serial. If you have an RMC100 with no Ethernet module, then the CPU has an RS-232 serial port on it that you have to communicate with. You can choose a serial port here. A very common problem is that your laptop doesn't have a serial port. So we recommend a USB to serial converter. We have one listed here. If you go to our website to support, see if it'll respond here. Looks like some problems responding, but if I get to the forum off our website, we have links to it. Looks like the support page open there. You can open the discussion forum. That leads to the forum. You can search for USB to serial adapter. That brings you to this topic. And we recommend this one here. And that's available from StarTech, and you can buy it off Amazon as well. It looks like this. It's an all-one USB to serial cable with a converter, and it works very well with all of Delta's products. So if you do not have Ethernet, we recommend this product here. Just plug the USB in your computer and away you go, and you'll see the serial port here and you connect to it. If you have Ethernet, you choose this option here, and the RMCWin will browse for all the RMC100s that are connected to the network. So we see on this network app, I have 3 of them, and we're using this one in the middle here. You can also configure the IP address. So here we see one that doesn't have it configured. You can click configure, set it up there. But right now I'm connected. I do have the option of closing the connection. I can click closed work offline here. But right now I'm connected via Ethernet to my controller. You'll notice here also we have a write and read mode. Write, that allows me to write parameters and send commands. If I go to read mode, it reads up everything in the RMC. There's cases where if I'm in write mode and I change a parameter, let's say I'll go change one on one of these axes I'm not using, like proportional gain to 2, it'll be read. If I change to read mode, it reads it up, you see right there? So it actually reads what was in the controller. The commands, I can see what commands are being sent through by a PLC, for example. When I'm in read mode, I can see that show up in the commands. We also have a, let's see, I wonder if the read mode is our look only mode. I believe read mode is the look only. So then you don't have to worry about accidentally sending commands and so on if you're in read mode. Makes it a little bit safer to look at the machine if you're not familiar with RMCWin. Another common thing that comes up is how to transfer projects from an old RMC100 CPU to a new RMC100 CPU. The newer products have just a single project file, but RMC100 can have many different files. So we have RMCWin, we call this the board file. You'll see it's demo.bd1. But if I open up other things like the event steps editor, this event steps editor, it'll have another file. We see here it's demo.st1. So if we look in what I'm actually using right now for my training, I have a few files listed here. So I have a BD1, a curve file, input to event, step editor file. And so all of those you have to upload from the controller, save them to your computer, and then download them. We actually have in the help a topic that lists the file types. We'll go to file types, and this lists all the file types that may be used in your project. Your project very likely doesn't use all of them. For example, the status map editor, LCD screen editor is fairly unusual, motion profile editor and stored commands as well. But many use the event steps and input to event editor. So all of those you need to upload them from the controller, and you can generally do them within each window that applies to it, such as this upload button, and get it from the controller. I see that it has some items here to upload it, and then I can save them. Hopefully though, you have the files from the original project. That makes it the easiest method to do. Another important feature to realize is that the firmware in the RMCs is not necessarily just one standard firmware. If we go to Tools, Module Configuration, and look at the CPU, click Slot Options. Sorry, that's the... Okay, it's on the main screen here, the firmware. You'll notice this firmware here has in parentheses 1 millisecond. If you have up to 4 axes, you have the 1 millisecond firmware. If you have up to 8 axes, you use a 2 millisecond firmware. That's the update rate of the RMC. In addition, we have special versions of firmware that you may have to be aware of on your machine. If you use pressure limit control, there's a special firmware. And then I think there's a special firmware for, I don't remember exactly. There are several different features that there's special firmware for. And so you will want to look at this when you're dealing with your RMC100. Oh, it was a superimposed move that we have for some reason or other that has special firmware. And then there's some that aren't documented very well. And it can get a little bit confusing. But if you call technical support at Delta, we can help you through that. Okay, the main window here. The status area for each axis is fairly simple. We looked at the position. Oh, let me go back here a little bit first. Let's go to Tools, Module Configuration, and look at how we've configured this module. So this module happens to have an MDT module with 2 axes, an analog module with 4 inputs, and I think this one has control outputs too. But we can click any one of these modules and configure it. So the MDT, I click Slot Options, and here we don't have many options. For either axis, we can choose standard or short, a blanking period. And I think if you're using an old Tempo 1 or Tempo 2, it's very important what you choose. For modern ones, it's not so important. The analog here, we'll notice that I have a RMC101. That means this thing is pressure enabled, so I can do the combination of position pressure control. The RMC100 would be only position or only pressure. You cannot do dual loop control with the 100. When I configure the analog by clicking slot options, I can choose what I want those analog inputs to be. Do I want them to be a position reference, such as right here, or position control, or auxiliary pressure? What that means is it's going to be the pressure input for my position pressure axes. And that's what I have selected here for channel 0 and 1. They're both auxiliary pressure. Channels 2 and 3 is the same. So if we look up in the help, it'll explain to us a little bit how those are connected, but it will connect the axis 0 position control to channel 0 on my analog module. So I now will have position control with my NBT over here, along with pressure control that's given by the first analog channel, which shows up right here as aux2. I can double click aux2, it lists that's the analog and it's an auxiliary pressure. So the combination of axis 0 and axis 2 gives me my position and pressure control. So this axis is actually able to do position and pressure. We'll just focus on the position for now. The counts show the raw feedback from the transducer. And keep in mind that the RMC100 is a 16-bit controller. 16-bit is fairly limiting, so there's some acrobatics we have to go through in the firmware to deal with the positions. We'll see that later in the scale and offset. The status, we can double click that, and that will open up the status bits. The first 8 are errors, no transducer, transducer noise, following error. And the last 8 are status bits, such as in position or telling us whether we're in an open loop. Very useful to look at the status bits to figure out what is going on. The first 8 here are connected to the auto stop over in this area. When anyone turns on, we can choose what happens to the axis, something you'll want to check. Following error right now, if it happens, I choose status only, so it's not going to halt the axis. Then we list the drive, that's the control signal to the valve, and that's in millivolts, actual speed. Null drive, that's the offset that we can set. For traditional servo valves, flapper, nozzle, or jet pipe, it's very common for them to come out of null, and so the null is kind of a big deal in the RMC100. Modern valves, well, I suppose those styles are still modern, but proportional valves typically don't get us out of null, so we don't deal with that as much in newer software. Then we have the step and link value that has to do with the event steps that we run. We'll look at that later. The command area. We have many different commands we can send. If we look at the command list up here, it lists all these commands. Some of them we can expand and see a few more. For each command, we have the mode word that applies, and it can apply in all kinds of crazy ways. So you have to look up in the help how the mode word applies. So for a regular go command, we can set the integrator mode, whether it's always active or not. We have different ways of specifying acceleration and deceleration. We can also define whether we want to do synchronized motion between axes or gearing for axes. We also have the quick mode where it starts in open loop and ends in closed loop. We call that the quick move in RMC tools. We can choose whether we want the velocity to have S curves or be a trapezoidal profile. Monitor pressure is for when we want to possibly enter pressure control. Rotational mode is if we have a rotary axis. And velocity loops lets us do a velocity PID instead of the position PID. And superimpose, that's for that special firmware that we have. So lots of different options that you can do just with a single go command. And it can become a little bit confusing sometimes. But the basic settings are fairly normal. The graph disable is kind of cool. You can, especially in the event steps, turn off the graph so that it won't start a plot when you don't want it to, and you can have it start a plot only when you want to. But let's look at this. If I choose this mode word just as it was, kind of the basics, and accel and decel of 100, and if we look at the mode word, it's actually 1,000 position units per second squared, which is a little bit hard to visualize. But these numbers here on the accel and decel actually end up being very similar to what you'd see in RMC tools. The speed, remember, that's in position units per second, and typically this is going to be in thousandths of an inch. So this is 5 inches per second. and command value of 6,000 is 6 inches. I'll move to 12,000 here, and if I press G, press enter, it will go. And again, remember, I can press insert key or the plot to view the plot. We see the plot here is 2,000 milliseconds. We can change the plot time up above. So I can change it to longer. I can change to 6, and it will just apply immediately. So now if I make a move, say 3,000, say go, press insert, get that plot. Now that plot time is longer. But the amount of data in the plot is the same. Each plot will be 1,024 samples regardless of the time. So if you make a really long plot, you'll be able to see that data, but you won't be able to see every loop time of that data. In the plot, we can choose options. Let's see, data, show detail window. There. We can see all the details of the plot. We can move the cursor. We can see the information here. Position, speed, this target and actual analog, that's the pressure feedback. And I can click to hide or show the status bits. So as I go along, I can see how the status bits move or turn on and off as I move. So this plot with the status bits is very useful for troubleshooting. We can also turn on other information in there. So if I go to options, extra plot data, I can choose to see, for example, the integral drive data, what the integrator is doing. That's very important for tuning sometimes. So if I do that, let's try that. Click OK. And then we make a move maybe to 4,000. Go, insert key, get that plot. Now we should see a yellow line here that indicates the integrator. And I can't zoom in here, but I can kind of make it bigger on the plot. We see a little yellow line that indicates the integrator. On the extra plot data, another useful one is the current event or link value, which tells us what event step is currently operating in the plot. So again, I want to stress the importance of this mode word in the command. It makes a big difference as to what exactly your commands are doing. If we look in the help topics and we go to the contents, command reference, general ASCII commands, let's see, we had a go. The go command is the one that uses probably the mode word most, but there's other ones that also use it. Let's see, it was IP, -PD position. Actually, okay, so this one doesn't say the mode, but if we go to the go command, it does indicate it used the mode, but notice the go command itself doesn't explain all those things. You have to click that mode word, and now you get to this topic that shows a lot of details with links to other topics. So just like in RMC Tools, RMCWin is actually fairly complete. It's a little bit older, and so there isn't as much as we have in newer stuff, but there's plenty of information for you to look there. Another common command is the open loop command. So if I set to maybe my command value to 1,000, that means 1 volt or 1,000 millivolts. Press O, enter. Now I have my drive is 1,000 and it's moving in closed loop. And -100 does open loop. Negative direction, and I can do go command and stop. Null command is also something that's very common. If I go with commands, that is the N. Where is it? Is it not? Null drive integral commands there. So update null drive will take the current drive, whatever it takes to hold closed loop control, and put that in your null drive. So if your valve is offset some, as it typically does, the traditional valves might take a volt to hold it. Well, if you do the null drive, just an N, When you're holding position in closed loop control like this, press N. Now notice that it stuck something in my null drive. That's very useful because the PID cannot handle having a big offset in the system. But if we use the null drive, that takes care of it, and then the PID can work better. So that's something you will see in older RMC100 systems is a null drive command. As we're doing motions, if you just want to start a plot at any given time, you just simply press Y, and it doesn't matter what the parameters are for that. Press Y, and now you do insert, and now we've got a plot at that moment. Of course, it's not very interesting here because we were just staying still. But if your machine is running and you just want to see a plot at that time, just press Y and it will go. And of course, it'll show a plot for that axis. If you want to see a plot for another axis, you have to see that plot. Aside from the additional plot data that's available in the plots are not configurable like they are in our newer software. Going on to the parameter side, this is where we configure the axes. This isn't the only place we configure the axes. Part of it is in the tools module configuration. So if I look up I'll bring in another RMCWin project here that has other modules. I go to tools, module configuration. This one has SSI. If I look at the SSI, click slot options, this is where I choose binary versus gray code, number of bits, a few other options here as well. We have a count offset that we can use with the SSI. We have that for both axis 0 and axis 1. Resolver has some options, but resolver is very uncommon. Quadrature has a couple of options only related to what the fault error bit does. And the sensor DIO, the discrete IO, you can choose whether to invert inputs or not. And then there's, I think for specific input, we have a counter type where you can do some fancy features. So these are all things that when you're working on an old RMC100, you will want to look at the configuration for that module to see what the settings are. Or if you're replacing a sensor, for example, SSI, you'll want to go in here and make sure that you're matching the right settings for that sensor. So some of the settings is in the tools module configuration. The rest are in the parameters here. The config word has quite a bit of settings in it. So right here we have SSI. A lot of settings were in the tools configuration. We have this transducer prescale that has to do with the scaling and offset. And then we have some other ones where we can do absolute mode, reverse drive mode where we invert the output. Absolute mode, I think we call that unidirectional mode in RMC tools. And if I go over to the MDT here that I'm using, look at the config word, this is where I choose start, stop, or PWM. And I can also, if I have a pressure axis, I have to choose here which pressure axis I am actually using together with that axis in order for it to work. Then we have the scale and offset. The scale and offset have some craziness going on with it. Being this is 16-bit numbers, it's kind of confusing to figure out what's going on because we had to really do some acrobatics to make it work. Generally, it's nicest if you just use the scale and offset tools, like here for the NBT. We have this feature here where you can enter the gradient, and if you're replacing a sensor, you will have to update that gradient and also update the offset. Fairly straightforward. There's some information on the help about that as well, but very similar to RMC tools. But there are situations where the PLC is calculating a scale and offset, and that's where it gets a little bit challenging. In the offset, for example, we can represent this in a couple different ways. I can right click and choose toggle offset sign and actually see the raw number in an int form and not a signed integer form, because this is the way it may show up in the PLC. If you do need help with the scale and offset, maybe your PLC is calculating it and you update a sensor and you're having trouble, give technical support at Delta a call. It generally takes us a little while to wrap our heads around this as well. Our newer software with 32-bit numbers is much nicer that way. We have the extend limit and retract limit that we set in position units. And then we have the tuning gains here, the feed forwards and gains. Deadband eliminator, our in position tolerance, and our following error tolerance. And these two kind of define in the auto stops, or in the status bits, when the error turns on, the auto stops decide when it halts. When you make a change in a parameter, you need to apply that with the P command. We'll go change this to write mode now. And we can click the P command if I make a change. So I'll change this to a 180 and click the P command, and that applies that to the axis. The P command will also put the axis in closed loop control and hold position. So you can't change the gain on the fly from here while you're moving. You want to wait till you're stopped and then change it, and then do the P command. You'll see that it has an Alt P on it. If you want to halt the axis in closed loop control, you can click the H button. If you want to halt the axis into open loop control, you can click the K button. That also has a keyboard shortcut, Alt plus K. Anytime we make changes in the RMC and download it, we need to also update flash. So we save to flash with this button here, or press Alt plus U, so that it's saved through a power cycle. These shortcut buttons are for making moves. If we go to the tools, stored command editor, it shows us which commands are going to be sent. If I press Alt plus 1, it will send this command. And it depends which axis I'm on. It will do it per axis, so I see I have it differently for all axes here. Or Alt plus 4, it'll send this command. Now, it's a little confusing because if you actually click the button, it will only send the command and the command value, not the whole thing. But if I press Alt plus a number, it'll send the whole thing. But a lot of times I can use this mode accel decel speed. So if I just press 2, it will move me to 8,000 using these accel decel speed parameters. So that's a little overview of what we have. You notice I clicked here on an auxiliary axis, and that changed all the status to what they are for the pressure. So I see the command target pressure. We're actually using aux2 here, so we can look at that. We have the actual force A and B and drive, and it lists also the command parameters that are typically used for a pressure command. But this is kind of the basics of the main window and the basic position control that you see in the settings you need to look at. A little bit about the troubleshooting features we have available with the status and the plots especially. Now I want to talk about another major item, and that is the event steps editor. Let me open up the file I was using here. Not that one, let's see. Okay, there. So open up this file, and you'll see it has comments in it. They're listed by the yellow. If I click that, I can open up the comment, and as I click to different steps, it updates to show the comments for the steps. Unfortunately, the comments are not stored inside the RMC. So if you upload the event steps, you'll get the data, but not the comments. So hopefully you had the original file saved and you'll get the comments to make sense of it. The event steps have steps where the first part is a command right here, the commanded axes, and then it decides how to link to an axis. So right here we see I have some data, I have a sequence, a very common type of sequence where I have some go commands with a G. The open bracket means I'm turning on discrete outputs. Here I'm doing nothing, I'm just delaying a little bit. Then I close the brackets. The close bracket turns off a discrete IO, and then I go to step 5 with the go command. And you'll see that it also jumps back to step 0. Step 0 we typically reserve for an end. Just good practice to do that. So here I'm doing the go command, and this link type, if I double click it, it tells me what's going on. So this is looking for the current axis, the status bits, wait for one or the more of the following to be on the in position. Okay, so this step does a move to 20,000, that's 20 inches, then waits for the axis to get into position, then it jumps to step 2. Okay, so we got that. And the description also should tell us that, hopefully. Step 2, we have this command, turn on discrete outputs, and the command value says which discrete output to turn on. And then we do a delay. That's just a delay here, and we decide how many milliseconds. Right now we're doing 0 milliseconds, so that means we jump to the next step immediately, or the step we define. It doesn't have to be the next one, it's the one that we define. So step 3 jumps here. This one delays for 3,000 milliseconds, jumps to step 4, turns off the discrete output. This command value defines which one, so it turns it on and turns it off, same one. Then it does a delay millisecond of 0, which means it immediately jumps to step 5, which does the go command. Bits on X0001 is the same as this one here. So remember, that means just waiting for the in position status bit to be on. So just kind of a basic overview. There's lots of different commands here. There's actually situations where you can do looping and branching. So you can have a command that's actually a question mark that can make you jump to one location or the other. You can actually do some addition here where you take one cell and you add it with another and you put it in another cell. So it can get fairly complicated. And if you don't have the comments, then it's extremely difficult to figure out. But at Delta Technical Support, we can occasionally help you figure out what's going on in your system. So when we're running an event step, the common way to start it from RMCWin is that I enter the step number that I want to start at in the command value. So I'll enter 1, and then I enter an E, a capital E command, and this will run that sequence. When I run the sequence, you can see in the step status field that it tells me what step I'm on, and the link value will also give you some information. So if I have a delay of 10 seconds, I'll see in the link value that will start with 10,000 and it'll count down towards 0 milliseconds. So let's press enter on the E. Now we see the step went to 1, the position is moving towards 20,000, it gets there. Now the step is on 3 where it's delaying. It jumped to 5, which moves back down to 1,000. So we saw that happen there. Now I'm gonna, in the plot, make that a little bit longer. I don't know how long that took. Maybe we'll set 12 seconds, hope that's long enough. And in the plot, we'll choose extra plot data and we'll set to current event link value. Okay, and now we'll start that sequence again. And I'll press insert, and now we see the plot is capturing as it's moving. And then it moved down again. Okay, so we didn't capture the whole thing, but I can see in the details here as I move the cursor that my event number is at 1. So I'm event step 1, and I move on, and now the event step jumped to 3. So it really quickly went through step 2. And now it's at 3. We see right here it's 3. Jump down, event number 5, and it goes towards the end. Let's see, there's a question here. When we plot a trend, we have to click on the trend button at the right time or the trend doesn't show the actual move. I noticed when you clicked on the trend button, the trend of the move popped right up. Yes, so when you click the plot button, it will upload the current plot. If you have a lot of commands going on, then every new command will start a plot if the plot is not already going. So therefore, in the event step, sometimes, let's say I want to make sure to not start a new plot. When I'm doing maybe this command here, I can click the mode word and choose graph disable. And now it will not start a plot there. So if I want to see a plot from something else, not from that one, then I'm more likely to do it. So typically the problem not seeing the data you want is because the graph disable is not being used. But yes, that is a known tricky issue that you have to click the start plot or click the upload plot button at the right time. With the event steps, you can run an event step sequence on each axis simultaneously, but each sequence does not have to send commands only to that axis. I could have a sequence somewhere in the end, maybe I stick it at 128, that's sending commands to axis 3 and 4, but I'm running the event step sequence on axis 1. So the event step sequence here is actually kind of like an engine that each axis has to run event steps, but those event steps can apply to anything. Another way to start event steps, aside from sending a command, and again, I'd like to mention you can send a command from a PLC as well. The other way is to use the input to event editor. So the input to event editor starts a command when a discrete input turns on. So right here, I've set it up so if discrete input 0 turns on, then on axis 0, I'm going to start event step 1. And I could start other event steps at the same time. So if I had like 10 here on aux 3, I could start an event step sequence there at the same time when input 0 turned on. And notice we have rising edge and falling edge. I can also start a sequence when the input turns off. So when input 0 turns off, I'll start event step number 7 on axis 0. So you want to make sure to always look at both the rising edge and the falling edge to see everything that's going on. Now on this RMC, I don't actually have a discrete input or I don't have anything wired up to the discrete input. So I'm going to simulate it. We actually have a command for simulating that. So let's see, this starts event step sequence 1, input 0. Let's see here. Okay, so that does the sequence we just did. So now I can use the command, let's see, it's called simulate rising edge. It's the squiggly bracket opening. And I'll use input 1, or no, input 0, I guess. Input 0 there. So input 0, squiggly bracket. Oh, looks like it already went there. Okay, squiggly bracket, press, and that actually makes it run. I see the event steps go 3 to 5, so on. One thing I want to mention here that I wasn't clear on at first. When I'm in write mode and I'm in the command, I just have to press that. Well, there's situations where I can just press the letter and it'll actually send the command and I don't have to press enter. I'm not quite sure exactly what the deal is. You want to be careful about that. As part of input to event, we may want to look at the discrete IO. So I have on the window menu, the IO bit monitor. Let's see, where did that one go now? That one went on my other screen. So this shows us the discrete IO in the RMC. Right now, I just have some on the CPU. If you have a DIO module, you'll have a lot more listed here. But you can see when it's on or off with the check marks, or when the output is on or off. So I believe on this sequence here that we were running, it turns the output on for a few seconds. So we should be able to see that go. So let's go ahead and we'll simulate that that input going on there. And so now it's moving to 20. The step should turn to 3 right there. And now we see the discrete output is on. So the digital I/O bit monitor is a good tool for you to tell if your discrete I/O is working properly. So that's about it for the event steps and the input to event. You can start the event steps with the input to event or a command, whether it's from RMCWin or via PLC. And there's a lot more to learn about the event steps. It can get fairly complicated on some of those sequences, but we won't go into detail here. All you need is enough information to get you started, and there's more information in the help and with Delta Technical Support. I want to talk a little bit about the curve tool as well. Some of you are probably working at sawmills and may have a saw line that's using curve sawing. So we have the curve tool where we can do curve motions. And usually in a sawmill, you're not using the curve tool. Usually the PLC is creating the curve and sending the curve to the RMC. But this gives a visual representation of a curve here. So for axis 0, I have this curve that I've made. Has cool editing features. You can actually do a multi-select and move things around, kind of scale them and so on. But we have this curve for axis 0. Looks like the time goes from 0 to 1020 milliseconds. Positions go around 9400 to 10,000, so that's like 9 to 10 inches. And we can download that. We can also save these curves to flash. They're called splines here typically in the RMC100. So this one starts at 10,000. If I move to 10,000, then I should be able to then follow the spline. And let's see, the command is F, I believe. Spline commands follow spline segment. And I don't think that one has any parameters. It just uses the, let's see, follow spline segment. Okay, command value unused. So it's just using the latest one we have there for axis 0. So I'll do follow spline segment. Actually, just wait, I'll change the plot to be a little bit shorter here. And then I'll do follow spline segment, press insert, get the plot. And here we can see that it actually followed that curve here at the beginning. The position there looks remarkably like the curve that we have here, especially if I make this curve a little bit smaller. Oh, I guess I can't make it smaller there. I can zoom a little bit, looks like. There. So when you do the curves, curve tool is useful there. But we won't go into more detail on the curves. It's not used that heavily other than curve sawing. There's a few other applications for RMC100, but not so common. I also want to talk a little bit about pressure control. There's a number of applications that use that. So as I mentioned, we define these as auxiliary axes. And for axis 0, we went into the config word and defined which axis was assigned to it for the pressure, so aux2. And let's see, if we move the axis here, move to, let's see, 30,000, press go, look at the plot. Okay, that didn't catch everything. Guess I need a longer plot. I'll move back a little bit here. 20,000, go. Maybe I need to go to 32,000 as well. Press go, look at the plot. Okay, so there we see that that previous plot was going already when I sent the move command here. But here we see the gray line goes up. That's my pressure that's increasing. So it looks like around position of 30,000, it starts going up. and it ends going up about almost 31,000. So I can see pressure right there. So I can actually do pressure control. I have an event step sequence set up to do that pressure control. So step 10, I move to 29,000 with the go command. Once it's there, then I do this set pressure command. We see that it's this little hat symbol. And if I go look at RMCWin and click on aux2, I can see what the parameters are for that hat symbol. I have a pressure set A and pressure set B. Pressure set A here is 1,000. So when the pressure goes above 1,000, it will enter pressure control. When it goes below pressure set B of 500, it will exit pressure control. And 5,000 is the pressure that it's going to go to try to control. So I send this command ahead of time, setting up how it should enter pressure control with these limits, 1,000, and then exit it when it goes below 500. Then I jump to the next step and do a go command that moves the axis to a position where I expect it to reach that pressure, and then we'll switch into pressure control. And then we see steps 13 and 14. Now I do the set pressure command, and I'm changing the target pressure from 5,000 to 6,000 and 3,000, and then I jump back to 14. It'll go back and forth between 3,000 and 6,000. So let's try that sequence here. Maybe I'll set this plot of 12 should probably be enough. We'll move back to 28,000. And then I'll start that sequence. That sequence is at 10. So that's 10, and then E, and then I'll press insert, and looks like that plot was still going. Maybe we can, I'll have to do a Y to see that. Okay, so I missed the part where it's entering pressure, but we can see here that it's ramping the pressure up and down now. And we can see it's actually tuned somewhat well there. Let me try to redo that. Quit event steps, I think, is a Q, looks like, and then we'll move to 28,000. Set the plot just to 1 second there. So that plot is done now, and we'll set that to maybe 12. And then we'll run this event step sequence at 10 again and see that pressure control work when it's entering pressure as well. So we see here it's entering pressure right there. We should be able to see the status bits. Looks like I don't see there when it's entering pressure. I can probably see an aux2 here when it's at pressure and regulating pressure, those bits there. Show me what's going on. When it enters pressure right here, we can see the target and actual will be separate, and then it goes up and down. So that's just a very brief introduction, hopefully enough to get you going and looking to help. For more information on the pressure control, we will do a Q command to quit that, and then we'll move back to 20,000. I also very briefly want to touch on communications. So communications, we have Ethernet. That requires a separate module. Goes in the left-hand slot. The CPU only has serial on it, and only intended for RMCWin actually. But if you have a discrete I/O module, you can do some communication there. You see there's several different modes. Some of them are fairly complex. We have a Modbus Plus communication module. If you have a serial module, you can do RS-232, 422, or 485 with these protocols listed here. And we also have Profibus DP. I'm not going to go into detail on most of these. I'll briefly touch on Ethernet, being that's the most common one, or at least as in later years of the RMC100. With Ethernet, there's two protocol groups, and you need to make sure you have the right firmware for them. So be aware there's two different firmwares. First one is most common with Ethernet IP or Allen Bradley CSP, which is DF1 over Ethernet, and Modbus. Protocol group F is for Siemens, and this other SIMATIC 505, which is not very common. So with the cyclic I/O communication on the RMC100 and the PLC, it's fairly simple. The status area is always going to be sent to the PLC, so it gets, it's called produce data or something inside there. It gets sent to the PLC all the time, and the PLC has its output data that's always sending to the RMC's command area. So you don't get a choice. It's just the PLC always reads the status area with the cyclic Ethernet IP I/O, and it's always writing to the command area. There's one thing that's important beyond the fact that it's sent at the requested packet interval, so every, say, 20 milliseconds or 10 milliseconds, whatever you have it set, is that we have a sync register. And the writes are applied only when the sync value changes. So in the PLC, you'll see your array, and the first item is the sync register, and the rest is the data you're writing. That gets sent to the RMC, and the RMC sees it, but it doesn't apply it to the command area until that first value changes. Then when it changes, it applies it, and it also echoes the sync register back to the PLC. Oh, sorry there. So from the PLC's end, it's really nice because it can tell when the sync value comes back, it knows the RMC has received the command and processed it, and then the PLC can proceed forward in its logic without getting messed up. I'll show you very briefly here with control logics how we have that set up. Let's see. So I have my status area here, and in the control logics we have the Ethernet module defined here as a generic Ethernet module. I called it RMC100, and then it makes some tags here, RMC100:I, that's our input data. So we see that that's the data we have here. I have 20,000, 20,000, 19, and so on. That's the same data I have listed over here. This first one is a sync register. And then the output data here, if I would write to it, it would go to the command area with the first value being the sync register. Now I've thrown in a little bit of logic here in the main routine. I'm always copying the input data to some nice user-defined tags so I can see what's going on. And so in the controller tags, that is the write data and the RMC status. And so I can see the access status here. I need to go to monitor tags, I guess. And I can see those values from access 0. And I can also see them from access 1. And if I want to send a command, I go here on access 0 command. We can set the values. So here I have a mode word of 1, Excel decel of 150, speed 2100, command value 19,000, and command is 71. That is the decimal value of the G, letter G, which that's available in the help for every command what the decimal value is. And so this data is getting sent to the RMC all the time, but it won't be applied until I set that sync register. And I actually made another tag with it and added some logic that just copies it, so simpler. So I'll just change that. Doesn't matter what you change it to, it just has a change. So I'll press 1. And now we see over here in RMCWin, notice that it moved to 19,000, just like we commanded it to. Now I'll change it to move to 3333. And over in RMCWin, I'll move my cursor away from this axis and I'll put it in read mode. And now I can see that this command will update with what is being sent to it. So let's go change the sync register here. Sync out, we'll change that to 2. Sorry, clicked the wrong thing there. Let's see. Oh, no, I didn't change that, did I? Let's see, 3333 command value. Looks like I typed the wrong thing. and then change the sync out to 3. Okay, there we see that it's moving towards 3,333. And we see in the axis that it showed us what command came through. So this is a nice troubleshooting trick, is to be able to see what's coming through. Sometimes if your cursor's on the axis, doesn't update, you have to move away from the axis. That's kind of a general thing within RMCWin. If you're on the axis, you might not see the updates. You move away from the axis and you can see it update. Some other tools related to that are the window Ethernet activity log, statistics, internal state, and also the command log. So the command log shows the commands that have been sent to the axis. So I can see that it's come through from the PLC. So I got a go command to 3,333, before that to 19,000, before that to 19,000. And you can see it per axis. So very useful tool for troubleshooting the commands coming from the PLC. Let's look at that Ethernet activity log. This shows us just when connections were opened or closed, which IP address. So that can kind of help you with some troubleshooting there. We have Ethernet statistics. These are a little bit more cryptic, show if we have problems on there. The Ethernet on the RMC100 is 10 megabit half duplex, and that can be challenging sometimes. If you run into big issues, you may want to try updating your Ethernet firmware. The Ethernet internal state shows us all the connections. Right now I see that I have Ethernet IPIO with the PLC at .101. And there's some other ones. One of these would be the RMCWin connection. I'm not sure which one. One more item for communication is the message instruction. That is very common. You'll see that in older PLC 5s, for example. And in the main routine here, I have a couple rungs that do this message instruction. And of course, it's going to look different in the PLC 5 or SLC than it does here in ControlLogix. But in general, we typically do a PLC 5 word range write or a SLC type reader write. And here I'm writing from the write date in the PLC to N7:80 in the RMC. Now in the RMC, we have this tool called, I guess under window maybe, is it? Address tool. So you can hold it open and choose your address type, Allen Bradley. And if I click the mode word, that address tool will show the address N7:80. And the command is N7:85, so it goes from 80, 81, 82, 83, 84, 85. I can see that up here as I move my cursor through the commands. So good, quick way to find addresses in various places in the RMC. And of course, the addresses are listed in the help as well. So this is taking write data, sending it to the command area, writing 6 values, so it's just doing one access. So if I look at my controller tags, and I look at that write data tag, let's see, what was it? Write data, monitor. So I'm sending a 1, 33, 33, and so on. That's going to become a command. So it looks like I have data there to move to 4020. And if I go to the main routine, toggle this do message, it should send it. And we see here that I did get that command 4020, and it moved the access to 4020. And we should also be able to see in the command log that I got that command, a go command to 4020. Yes. With some of the communication types, you will use this profile editor. Let's see right there. And basically you have to set up these moves ahead of time in the profile editor, and the communication just tells the RMC which one of these profiles to use. I don't remember which communication methods use it, but that is one possible thing to look at. So with communications, there's a lot more to look at. I went through just briefly the two that are most common, the message instruction and cyclic Ethernet IPIO. If you need help with the others, there's help in the software help. and you can also call Delta Technical Support. So with that, this is a very quick, brief overview of the RMC100 and RMCWin, with kind of the focus on learning the different areas and learning troubleshooting tips. You may notice that we don't have as much troubleshooting capability in the RMC100 as we do in our new software, but there is plenty there, and we're willing to help you at Delta Technical Support. So with that, I thank you very much for attending.
Thank you very much, Jacob. Very informative and helpful webinar. Just want to thank all of our audience for attending today. I mentioned at the top that recordings of past webinars are available. This one will be available as well. Recordings are available first at our website, deltamotion.com. You see the address there on the screen. deltamotion.com/education. If you look on the education page, you'll find a link to a dedicated webinar page. You can find recordings there of all of our past webinars, and then you can also see the upcoming schedule as we finalize it, and there'll be links there to register. Another place that you can find recordings are at our discussion forum. That's forum.deltamotion.com. If you haven't gone there, that's a great place to have a discussion with other RMC users and get suggestions maybe on new applications. There is a webinar topic that is pinned at the top of the forum. You can find it there. And finally, youtube.com, if you search for Delta Motion Control, all one word, that is Delta's channel. And there are several playlists there, including our webinars.